Variation of parameters is a method for creating a particular solution, so a YP, out of a complementary solution, so a YC given by some linear combination of Y1 and Y2. So you should definitely go ahead and find the complementary solution first before using variation of parameters. So the name variation of parameters comes from the idea of letting these parameters C1 and C2 vary. So in particular, we're going to replace them by functions of x. And so the idea is to look for a solution that's a linear combination of the two parts of the complementary solution that you found, but now with coefficients that can vary. So the idea is to look for something of this form. Okay, it's probably easiest to show it by example. So let's consider the following example. We'll look at x squared y double prime minus 3x y prime plus 3y equals 2x to the fourth sine x. Okay, now the first thing to notice about this equation here is that it is not a constant coefficient equation. So in particular, right, we've got functions of x here and here. So that's something new. We don't actually know how to find a complementary solution for something like this yet. So suppose we are given the complementary solution. So it turns out that x and x cubed are both solutions for the associated homogeneous equation here. How did we come up with those? Well, don't worry about that for now. That's not what we're up to just at the moment. Okay, so let's see. So we make our guess that the particular solution is going to be u1x plus u2x cubed for some functions u1 and u2. Okay, so then we'll substitute this back into, so substitute guess back into the ODE in hopes of solving for u1 and u2. And then if we find u1 and u2, then of course we're done because we can build our YP from it. Okay, so we're going to need YP prime to substitute into that differential equation. So this gives us u1 plus u1 prime x plus 3u2 x squared plus u2 prime x cubed. Okay, now let's just think about what we're going to do before we go ahead and compute the second derivative yp double prime here. So we're going to have one equation when we substitute this in, right? So we're going to take yp, we're going to substitute it into the equation, so we're going to have lyp equals 2x to the fourth sine x. Yeah, that's going to be our single equation. But we have two unknowns that we're able to solve for. That means we have an extra degree of freedom. So we're going to have like a one-dimensional space of solutions, right? And there'll be different linear combinations of u1 and u2 that will satisfy it. This means that we have the freedom to add a constraint. So this seems fishy and suspicious often, but it's actually, it's okay. It's legitimate. I'll talk a little bit more about it in a moment. But for right now, just keep in mind that since we put in two unknowns and we have only one equation, we're free to add another equation to pin down a specific choice for those unknowns. So I'm going to make the following choice. I'm going to make the constraint that u1 prime y1 plus u2 prime y2 is equal to 0. Okay, so I'm going to require this constraint. And the reason why is because I want these terms to go away. Because then when I go on to the next stage in my derivation, I won't have any double prime terms. Right? If those guys in the green box were still around, then I would have u1 double prime and u2 double prime. But if I choose those ones to go away, then when I differentiate, I just have u1 prime plus 3u2 prime x squared plus 3u2. Oops, and then let me combine the 2 and the 3 there for the 6. Okay, so now if I feed this into the equation, LYP gives me, and so my first bit is exactly this one that I just computed in the previous step. And we have that much times x squared, and then our next part of the equation is minus 3x times, and then we have the yp prime from the line above, so u1 plus 3u2 x squared. And then we have plus 3y. Oh, sorry. Y is u1 times x plus u2 x cubed. And this is all supposed to be equal to 2x to the 4th sine x. Okay, so let's see what we've got then. Looks like we've got some cancellations here. u2x cubed. Let's see. So I've got 6u2x cubed, and then I have minus 9u2x cubed, and I also have a plus 3u2x cubed. Okay, so that's a total of 9 minus 9. Bam, bam, bam. And let's see what else I have. 3u1x and minus 3u1x. And there we go. So it looks like I'm left with u1 prime plus let's see, 3u2 prime x squared equals, and I'm going to take that that x squared and divide it across from the other side, so this becomes 2x squared sine x instead of 2x to the 4th. So I just divided it out of here. Excuse me. Okay, so that's my one equation, but then we also had our constraint that we imposed. And so if you look at what we have right here, this is actually a 2x2 matrix system, right? So we've got x cubed, 1, and 3x squared. multiplied against u1 prime, u2 prime, and that's giving us 0 and 2x squared sine x. So we can solve this by row reduction. And row reducing, we find, let's see, so we're going to get, maybe I'll do 3x squared, 2x squared sine x as my first row. And then multiply that by x and subtract it from the second row, and we'll get a 0 and minus 3x minus 2x cubed, and minus 2x cubed sine x. So that one, after the row swap, row 1 and row 2, I did minus x row 1 added to row 2. And so then let's see. So now I've got, can divide through by the minus 2x cubed. And then subtract what, I guess, 3x squared times the second row. So minus x squared sine x. Okay. And so let's see then. So now this is telling us what our value, what our u1 prime and our u2 prime are. Okay. So now I can take, so u1 prime is minus x squared sine x. So integrating, I get u1 is, well, let's see. So that's going to take some integration by parts and blah blah blah. So we end up with x squared cosine x minus 2x sine x minus 2 cosine x. And our u2 prime was the much simpler sine x. And so again, we integrate that guy and we find u2 looks like minus cosine x. So now notice that there should be, morally speaking, there should be a constant attached to each one of these, right? But here's the thing. We're looking for a particular solution, and so we just need to find a single thing that works, right? So I'm allowed to choose the constant to be equal to 0 because I don't need the general form of something. I just need one thing that works. So I'll just take c to be equal to 0 in both cases to make my life simple. Okay, so then my yp is u1 y1 plus u2 y2, which is apparently this business. Copy and paste times y1. What was y1? y1 was x. And then minus cosine x times x cubed. And so it looks like I've got some cancellation there. I've got a minus x cubed sine x and an x cubed sine x right here. So that leaves me with minus 2x squared sine x minus 2x cosine x. Yeah, there we go. That is our solution.